Good day, Algebra 2 students. Today's lesson will be notes on logarithms, and today we're going to be studying the properties of logarithms. Over the course of this year, we've noticed that it's always studying the graphs of new equations and then studying how to solve them and manipulate them, and a lot of times they have different properties and whatnot. So I have three properties here we're going to focus on today. Well, let's go ahead and start with the ones at the very top, their product property. Now, what you see here in this box is two ways to write the same thing. You can have the logarithm of some base of two numbers that are being multiplied, let's say. And in this case, they just put them in parentheses to show you that that's two actual different numbers, m and n, that are being multiplied. You can split that up, expand it in other words, and you keep the base that you have for both of them, and you just say, the logarithm of base b of m times n is the same thing as the log of base b of m plus the log of base b of n. So it's two ways of writing the same thing. You can have some number, you get two different numbers with the same base, and you combine them or condense them to make them smaller and just multiply them. And that's what we're going to see in our first three examples. And this is actually the basis of your assignment for this week as well. We're going to be condensing problems into a single logarithm, simplifying whenever possible. So for number one, we have log base 2 of 7 and plus the log base 2 of 4. Always verify that you have the same log base, in this case 2, so we're good there. And we can go ahead and begin by writing, okay, log base 2. Our property over here says that when we're adding two different logarithms with the same base, we can simplify them by multiplying the numbers of those logarithms, in this case the 7 and the 4. So I can say, okay, log base 2 of 7 plus log base 2 of 4 is the same thing as log base 2 of 7 times 4. Only difference is they put it in parentheses in the rule. I can do that here if you want to see where the parentheses fall. And then you go ahead and just multiply those out. 7 times 4 is 28. So we can condense this expression into a smaller one and just say the log base 2 of 28 is the same thing as the log base 2 of 7 plus the log base 2 of 4. So it's basically going one way or the other. Now, number two, same exact kind of idea. It says log of 25 plus log of 4. Remember, if you don't see a small base number, these are automatically assumed to be the natural log, or basically a log of base 10. When it's base 10, you can just ignore it, because log by itself means base 10. Okay, that's why you don't see a number there. So going on, according to our product property, if we have the same log, in this case, the natural log base 10, we can just go ahead and multiply the numbers that come after it. So 25 times 4. 25 times 4 is 100. So we have log of 100. That's the condensed version, the smaller version. Number three, we're adding, so we're going to have the product property involved. We have log base 4 for both of them, so we're going to begin with log base 4. And we're going to go ahead and multiply 2x times 4x squared. 2 times 4 is 8. X to the first power times x to the second power. We go back to the rules of exponents now. 1 plus 2 equals x to the third power. So we have log base 4 of 8x to the third power. Those rules for exponents will come back and haunt you for better or for worse in this assignment. Not in a huge degree, but they will be playing a part in this week's lessons and definitely next week's lesson, all right? Now, what the next set of examples, 4 through 6, actually use the same product property, but they're going in reverse. They're saying if you have a small or a condensed version of a log, could you expand it or make it bigger? And you see over here there's a side note that says answers may vary. And that's because you can have different ways to get to the same number. For example, I can use the product property backwards, and I can ask myself, what two logarithms would give me a log base 10 of 6? Well, I could say log base 2 times 3. In that case, I could expand it even more and say log base 2 plus the log base 3. Expanding is not something we're going to really focus on, because generally in mathematics we want to make things smaller and simpler and not necessarily bigger and longer. But that may change with next week's assignment, because sometimes you need to expand things in order to ultimately make them in their simplest form. You have to, break them up into their big, long constituent parts. That's more of a next week issue, but we'll continue learning it anyways in these notes. So now I have the log base 7 of 45. Well, what's one way to get 45? You could say 5 times 9. You could also say 15 times 3. That's why it says answers may vary. because there's different ways I could have gone to 6. I could have said 2 times 3 or 6 times 1 if I wanted to. So remember, there's different ways to expand because you have multiple options when you're trying to get these numbers. So to get a 45, they chose 5 times 9. If I want to really expand it, I could say, okay, that's the same thing as log base 7 of 5 plus the log base 7 of 9. It's just a longer way to write this already small expression. Log base 2 of 5 to the x. Well, that is two things. That is 5x means 5 times x. So I could expand that as log base 2 of 5 plus log base 2 of x. Like I said, expanding is not really going to happen in this assignment, but you will need it most likely for next week's assignment. All right, the next property we're going to practice now is the quotient property. And I'll give you a second to go ahead and write it down. The way you see it is when you have a log of some base common to everything in your problem, whatever that base is, b, and let's say you have a fraction problem, something divided by something else, m divided by n. You can split it up, and it's kind of like the opposite of the product property. Instead of adding, you could say it's subtraction. The way I kind of remember this property is this fraction bar means I'm going to have subtraction between two different pieces. In this case, it's the log base b of the top thing n minus the log base b of the bottom thing n. And then that's just the expanded version if you want. And we're going to be focusing on going basically the other way. You're going to be given two different terms with the same log base, and they're going to have subtraction between them. It's always going to be the first thing is your numerator over the second number is your denominator. So let's go ahead and look at that now. For 7, 8, and 9, we have a common log for both of these terms of 3. So log base 3. Since we have subtraction in the middle, we're going to use the quotient property. So we'll go ahead and take 24 over 8. Whenever you get a chance, simplify. 24 divided by 8 is 3. So ultimately our answer is log base 3 of 3. And you stop there. Continue this again. We have a log of base 2. And then we have subtraction, so quotient property is going to be invoked again. 15 divided by 15. What's 15 divided by 15? 1. So we have log base 2 of 1. And there's your answer. Condensed number 9. We have the same log of base 4. We have x to the 9th power. That becomes our numerator over x squared. That's our denominator. The rules of exponents, remember, when you have the same base, in this case x, and you have different exponents, 9 and 2, you subtract the top one minus the bottom one. So 9 minus 2 is 7. That's where that x to the 7th comes from. These rules will come back. Remember, I told you. So make sure you have either a digital PDF copy, or you can even do a basic Google search of just rules of exponents. Excuse me. And actually, you may want to even find a more, not a more better, you might find an even more precise search. If you do rules of exponents and logarithms, I think you're going to find some interesting similarities between the two. But that's on you if you want to go that far to explore. I know we only have so much free time being locked down in our houses lately. All right, and now to work on expanding logarithms. Once again, answers may vary. So, oops, I didn't mean to kind of lose focus there. Here we go. So for number 10, 11, and 12, it says, how do we end up with something that gives us a log base 8 of 4? So we know we're going to have two different logs with the base 8, so we have them here and here. And you just ask yourself, what two things can I divide something over something else that'll give me this answer of 4? The author of these notes just said, okay, well, 8 divided by 2 will give me a 4. Great. So I can say log base 8 of 8 minus log base 8 of 2. That's the same thing as log base 8 of 4. It's just another way to expand. You could have also used 4 and 1. You could have used, let's say, 24 and 6. Any fraction that would have given you an answer, 8 over 2 of 4. Same thing over here. We want to get a final answer of log base 5 of 1/3. So you need to come up with some bigger fraction, really, that'll simplify to 1/3. Here the author used 15 over 45. You probably could have used like 2 over 6, or 3 over 9, 4 over 12, 5 over 15, any combination that simplifies to what you want, which is a 1/3. They chose 15 over 45. Perfect. We have a log of base 5, common to both terms. The numerator becomes your first number over here on the left side. Your denominator becomes the second number over here. Bam, it's been expanded. no questions asked. Now we have log. Remember, it's the natural log base 10 of m over 7. That's the same thing as saying log of m minus log of 7. That's it. You just expanded it. Remember, we're not going to be expanding this assignment, so at least not yet. So make sure you do understand or have the basics of this. Answers vary because you can, for the most part, choose your own multiples. I suspect in the next lesson that given other parts of the problem, some numbers might be more compatible than others. And we'll get into that next week's lesson. Let's just take it 1 week at a time, right? So now let's go ahead and go on to our last example, which is the power property. This is when you have the log of some base, whatever it is, of a number raised to an exponent. And the trick is, all you do is you take that exponent of your number and you throw it in front of the word log, basically. So it's that little exponent now is going to get multiplied times log base b of m. So the only thing that really happens was that your exponent traveled. Everything else stayed exactly the same. And once again, if you see a logarithm with a number in front, no matter what the number is, in order to condense it to make it smaller, all you do is make it travel back over here and make it the exponent that would go right here in this spot. I'll draw little arrows there so you don't think it's the number 0 or something. So let's explore what that means. 13, 14, and 15. 5 times the log of base 4 of 2. Well, you just take that 5 and you throw it over here. Whoops. Take the 5 and you throw it over here after the 2. So you get log base 4 of 2 to the 5th power. But remember, simplify if possible. 2 to the 5th power just means 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, that's a third time. Times 2 again is 16, that's a fourth time. Times 2 again, your fifth time is 32. So 2 to the 5th power is the same thing as 32. So log base 4 of 32, that's it. It's condensed. How about 7 times the log base 2 of x? Well, that just means the 7 becomes the exponent attached to the x. And since we don't know what x is, we can't go any further. So we just have log base 2 of x to the 7th power, and we stop there. Number 15, 1/3 times the log of 8. Well, we go ahead and take that 1/3, you make it the exponent after the 8. Remember, when you have refraction exponents, that really means you have a square root. So 8 to the 1/3 means 8 to the 1st power to the 3rd root. So here's a little special reminder that things from earlier in the year come back. I'll talk about the complication or the difficulty level of these questions on this week's assignment after I get these last 3 examples done. So just bear with me, don't panic yet. So now let's go ahead and expand. Here it doesn't really say answers will vary because there's really only one way to go backwards. If they give you a logarithm of any given base, in this case 2, and they give you the exponent, all it does is travel to the front of the word log. So 7 times log base 2 of 8. Here we have x minus 1 is what's in the exponent. So something interesting happens here. X times 1, and look, we already had a 3 in front. That's still fine. Whatever your exponent was, or is right here, will get multiplied by whatever's in front. So x minus 1 is actually going to get multiplied times that 3 that was already there in front of the word log times 4. We'll go ahead and distribute that out. 3 times x is 3x. 3 times negative 1 is negative 3. So that's the new beginning part. And then still just times log of 4, period. So that's a little interesting one to practice with. And then number 18. So this involves a lot of rewriting. Well, not a lot, but some rewriting. Log base 7 of w to the square root of w. Remember, the square root of w is the same thing as w to the 1st power to the 2nd root, or 1/2. And that's what you have right here. So the 1/2, that's where this 1/2 comes from. All they did was attach it there. All right, so they rewrote it with an exponent of 1/2. You throw that exponent in the front of the word log, and there it is. I'm not sure if you're going to have one on this week's assignment. I'll go look over it right now really quick. And let's go ahead and just actually quickly glance at what else is also attached to this week's post online. So here's the notes. Your assignment's going to look like this. It's only 8 problems. Now, there's going to be 12 questions on the Google form. And this always interests me to who actually watches these videos and pays attention. I can always tell when I give instructions that are very specific to my assignments. So I think the first I think all the questions ask you for a final answer. But for the first, I think 4 or 6, I actually also ask you which rule or rules you're going to use to condense. Remember, we're only condensing, we're making everything smaller. So that's basically what the 1, 2, 3, 7, 8, 9, 13, 14, 15 examples from our notes were talking about. We're not expanding, we're condensing. All right, so your answer should be getting smaller in final form. Now, also, if you've looked at your grades, which I hope most of you have by now, it's a very interesting time and beneficial for you guys to just give me your best effort on your answers, okay? Don't panic so much. But as always, look at the Google form, practice getting these answers as best as you can. By Friday, I'll release the answers. You can always ask me on Tuesday and Thursdays between 9:30 and 11:30 in Google Classroom. But a lot of you have seen that I'm pretty much respond anytime. I really don't prefer the midnight, 1 o'clock morning questions. I do get we're all on a messed up sleep schedule. Trust me, I totally get it. I think I'm napping, I don't know, 2 or 3 times a day already. I'm still getting up early and all that stuff. Whatever. So give me your best solutions. For the Google form, I'm not asking to show your work, so don't freak out about uploading your work documents, all right? And then also attached in the post is just this little properties of logarithms graphic organizer. And it gives you the basic logarithm ideas, what we talked about last week, the 3 rules we talked about, and one we haven't talked about yet that you can actually try to explore on your own so you can understand it for yourself. It's going to involve a calculator, all right? And then just some other general notes about the log of x being base 10. All right, other than that, best of luck on this assignment. And if you have any questions, I look forward to your asking of them. If not, keep up the good work, guys. And I'll talk to you guys later. Please be safe, be careful, stay home, and take it easy. Bye.